So here we have another problem. Remember, it's the same denominator, so we can just go ahead and combine. So we have 10 minus a minus, that becomes positive, plus 2r over r squared plus 9r plus 20. So we're going to have to factor that denominator, right? And we can also factor, and I'm going to write the numerator in standard form, actually. So we'll get 2r plus 10 over r squared plus 9r plus 20. So we can factor out a 2 in the numerator. So it's going to be 2 times r plus 5. Right? We factor out a 2 from the first term and the second term, leaving r and 5. And then the denominator we need to factor with the x, right? Notice there's a 1 in front of the r squared, so we don't have to put our fractions here. A times c is 20, and then b are 9 down here. So 1 times 20 doesn't work. 2 times 10 doesn't work. 4 times 5, that does work. So let's do 4 and a 5. And they're both positive, so our factors are both going to be positive, right? Multiply to 20, add to 9. So down in the denominator, we're going to go and say r plus 4 and r plus 5. Now you can see we have same factors in the numerator and the denominator, right? We're going to cancel those out, and we get 2 over r plus 4. So 2 over r plus 4. All right. Oh, now look at this one, right? Now we have 3 terms, right? All with the same denominator. So what can we do here? Well, we can combine all of them and then work it out, right? So we have 4 plus x plus 6 plus x minus, the minus distributes, so we get a minus 1 plus x over x minus 9. So now we'll combine our like terms. We got positive x, and positive x. That makes 3x. And then we got 4, 6, it's 10. Minus 1 is 9. So plus 9 over x plus minus 9. Okay. So now we want to factor something out so that we can have the same factors in the numerator and denominator, right? The denominator is x minus 9. So what we can factor out of the numerator is not positive 3, but negative 3, right? So what times negative 3 makes 3x? That's going to be a negative x minus plus 3. Oh, actually, I'm sorry. I thought that we could make a factor of x minus 9 here, but we can't. So, yeah, because if we factor out the 3, then we'll just be, watch, let me go and do it over again. It's equal to, we'll factor out a 3 in the numerator. We'll get x plus 3, and that's over x minus 9, right? So we can't get the same factors in the numerator and the denominator, so we can cancel them out. So this is going to be our final answer. So sometimes you're not able to simplify. So we're going to say 3x plus 9 over x minus 9 as our final answer. Right? And sometimes it takes some fiddling around to figure that that's the final answer. So here we have the same issue. We have the same denominator. So we have x squared minus 4x minus 21 over x minus 7. So here now in the numerator we have the quadratic expression. So we're going to factor that. So we got a times c is negative 21. And then negative 4 down in the bottom. So it's just kind of obvious to me. It jumps out. So it's 7 and 3, right? So it's factors of 7 and 3. And then we need them to add to negative 4. So we're going to say negative 7, right? So multiply to negative 21, add to negative 4. So we're going to rewrite that numerator as its factors. So we have x minus 7 and x plus 3 over x minus 7. So do we have the same factors? Yes, we do. We have x minus 7, so we can cancel those out, and it's just going to simplify down to x plus 3. All right, let's see. Do we have more problems, or are we done? Yes, we have more. So then maybe I can do another one or two. So here we go. Same denominator. So let me just go ahead and say x squared minus 25 over x plus 5, right? And so here in the numerator, we can factor that, right? It's a squared minus b squared is equal to a plus b times a minus b, right? That's the pattern. And so with x squared minus 25, our a is equal to x, and our b is equal to 5. right? Because x squared is our first term, and then 5 squared is 25, so that's our second term, right? Minus b squared minus 25. So it fits the pattern, so we can factor it, and so we can go ahead and say x squared minus 25 is equal to x plus 5 times x minus 5. So we can go ahead and rewrite this. We can rewrite it as x plus 5, x minus 5 over x plus 5. So we have the same factors in the numerator and denominator, and our answer is going to be x minus 5. All right. So now we're here. So here the denominators are not the same, but we can make them the same. Okay. Let's see. Can we make them the same? Yeah, we can. So we can go and say t squared over t minus 3. Right. We want the denominator to flip the signs of each term. Right. So how can we do that? We can multiply by -1 over -1. Okay. And what is -1 over -1? That's 1. So we're multiplying this term by 1. That's fine. We can do that. Right. That's legal. You can multiply any term by 1, and it's just the same term. So now what do we get when we do that, though? We get, we multiply straight across, right? So 3 times -1 is -3 over, and now this -1 is going to distribute out, right? It's going to multiply here and there. So it's going to be -3 plus t. And now we want to go ahead and just rearrange the denominator, right? Just write the t term first. So we'll get t squared over t minus 3 plus -3 over t minus 3. Okay, great. So now we have the denominators are the same. How do we do it? Well, we needed to flip the signs, so we multiply by -1 over -1. Okay. So let's combine them now. So we get t squared minus 3 over t minus 3. And can we factor this out? Well, does it fit into the a squared minus b squared formula pattern, right? Well, if it did, our a would be t, and our b would be the square root of 3, right? And we don't want that, because then there'd be no common factors to factor out. So anyways, this is the simplified version here, so I'm going to box it. So we have t squared minus 3 over t minus 3. And now we're here. We need to go ahead and simplify. We're going to use the same trick, right? Because in the denominator of the second term, we need to flip the signs. So we're going to do the same thing, which is to flip the sign, we're going to take the second term and multiply it by -1 over -1, right? Which is just 1. We can do that. So then we'll say that's equal to 2p over p minus 1 minus -2p over -1 plus p. Right, so if we multiply straight across, the 2p becomes negative, and then we multiply straight across, that -1 distributes out, so it becomes -1 and positive p. Okay, and then we're going to rewrite that denominator. So we'll get 2p over p minus 1 minus -2p over p minus 1. All right, we just rewrote we just moved around the terms and wrote it in standard form. So now that both the fractions have the same denominator, so we can combine them. So we get 2p minus, or I'm sorry, it's minus a negative, right? It's minus a negative, so that becomes positive 2p over p minus 1. Yeah, I thought it was going to be 2p minus 2p, so I was like, okay, all that work for nothing, because then it would be 0 over p minus 1, which is equal to 0, right? So anyways, I'm kind of satisfied that it's a positive 2p. So now we go and we say 4p over p minus 1. And so do we have any common factors that we can factor out? No, we don't, right? So that's going to be our final answer. So we have 4p over p minus 1, and we'll call it a day.